Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry, the Mystery of Molecules. Today's topic of discussion is one MCQ about related to biomolecule synthesis. Okay, see the question is in front of you. You have to say what is the major product of this multi-step reaction. And there are 4 options and one of them is the right. I request you student, please pause the video, try by yourself, and whatever answer you get, please write in the comment box along with few words as explanation. Remember, self-evaluation is essential for improvement and that's why you should try. I believe you have tried by yourself, so it's my turn to give you the right answer. Now if you look at this overall chemical reaction, it's not that much complicated. Why? The starting material, it's pretty simple student, it's acetone. It's actually simplest ketone, but there are multiple reactions. So let's learn everything stepwise. But before going to details, if you look at this molecule, this ketone has another canonical form. Means here you can see this is O minus and this carbon is carrying plus charge. And that's why this carbonyl carbon is electron deficient or electrophilic. Consequently, any nucleophile can attack it. And if you look at the first stage of the reagent, this is monosodium acetylide, means this is an acetylene's monosodium salt. So this is the sodium plus, and actually student, these can act as nucleophile, okay, because it is actually an sp carbanion. So it's significantly reactive, so it can act here or here, you can say, and it can open. So this is the first stage. So let's learn everything stepwise. So first step is this. First it will produce this O minus, means you can consider that first step will be O minus and Na plus, and later during this workup it will be converted into the corresponding alcohol. Generally student, in case of multiple or multi-step reaction, after every step workup is not mentioned, but you have to understand that this is the general unwritten strategy of any chemical reaction. Now this is student, this is actually a propargylic alcohol. This is alkyne and this is alcohol, and this here is talked about this Lindlar catalyst. This Lindlar catalyst is nothing but hydrogen, palladium on barium sulfate or calcium carbonate, etc., and along with that quinoline or sulfur is used as catalyst poison. Why this poison? Such that the alkyne selectively reduces to alkene. So it is actually partial hydrogenation by hydrogen. Sometime I have seen that students write everything, this palladium, barium sulfate, quinoline, etc., but they forget to write hydrogen. Don't do that mistake. Hydrogen is actually the reducing agent, palladium is the catalyst, and rest of things are responsible for to stop the reaction in the alkene stage. And in this case, actually this reaction produces cis alkene, but since initially it was hydrogen and in product there are 2 hydrogens, so it doesn't matter cis or trans. But remember, hydrogen transfer happens in cis fashion, same side. Now in the next step is given phosphoric acid. Remember student, phosphoric acid is pretty strong acid. It produces H plus, and which is expected to protonate this alcohol, because there are 2 sides, either OH or this alkene. This alkene is softer base but hydroxyl is harder base, so it will be protonated. And remember, this is actually allyl alcohol. This is double bond, and that's this. So this is allylic alcohol or allyl alcohol, and after this removal of OH2, because OH2 is a neutral leaving group, so its elimination is easier, so it will produce, this is actually tertiary and allylic. So this is highly stable carbocation, okay, and it has a resonance or canonical form, means this bond can come here and positive charge goes to this position. Now if you look at these 2 positions student, the interesting thing is that in this case it is primary carbocation and this is tertiary carbocation. Now question, who is more reactive? Tertiary carbocation is more stable, so it is less reactive. Primary is more reactive. Point number 1. Now you can say that, sir, if it is less, means more reactive or less stable, then its contribution in the overall electronic, means positive charge distribution is less. I agree, student, but it reacts with the nucleophile faster. Why? See, if you consider this tertiary carbocation is the electrophilic center, so nucleophile need to approach here. So nucleophile have to face the bulkness. I'm talking about these and this part. Okay, but if you look at this primary carbocation, so this position is, student, less bulky, so nucleophilic attack is favored here. Okay, and here if you look at this enol-ether is actually nucleophile, and how it acts as nucleophile, if you look at the canonical form, so you can understand it has two lone pairs of electrons, so it pushes, it goes. So in this way it produces this OMe carrying a positive charge, and this carbon is carrying the negative charge, and carbon is softer in nature. That's why nucleophilicity is observed from the carbon side and it attacks. Okay, so after attack, what happened? Now student, whenever you do such kind of long chain moiety, relatively long chain, I'll say, please be careful about carbon count, because this is 1 2 3 4, so this is 1 2 3 4, and these molecule contain 3 carbon, 1 2 3, so 1 2 3, and there is a 3 and 4 bond, so here is the bond between 3 and 4. Now it is correct. So after this nucleophilic attack, you can see this oxygen is carrying a positive charge, and we know that these carbonyls are electrophilic, fine, but if you compare this carbonyl with an protonated version, this is, student, even, sorry, carbonyls are electrophilic, so this is even more electrophilic. Okay, so more electrophilic means more electron deficient, means more reactive, such that weaker nucleophile like water can attack. First it will attack here, it will open, fine, and in the second phase what will happen, that these OMe will leave and ultimately it will be converted into this ketone, because this product is not that much stable, but ketone is stable. Remember, C double bond O is a stable bond. So this ketone will be produced, and with respect to ketone, if I say this is alpha, this is beta, this is gamma, so gamma position double bond, so this is alpha, this is beta, this is gamma double bond. So this part also you should be careful while getting the product. So this is the overall product. Now, so if you look at the name reactions associated with this, every step is, first step is nucleophilic addition to ketone to get this propargylic alcohol, and remember this sp hybridized carbon is significantly acidic, that's why such kind of alkynate salts could be produced. Second step is hydrogenation of alkyne selectively to alkene by Lindlar catalyst. Third step is alcohol dehydration in presence of strong acid, more specifically if I say allyl alcohol. Fourth step is resonance, and fifth step is enolate as nucleophile, and in this way CC bond formation occurs. And fifth step is this hydrolysis of this positive charge containing carbonyl derivative to get the final ketone. Okay, so this is the answer. Now what is the answer here? Option C, student, is the right answer. Now if this question appear in your exam less than 30 seconds, how can you come to the right answer? See, this reagent is less bulky, so it's easier, no, don't need to be considered. Now first step you need to understand that first step is nucleophilic addition, and in this case student, I suggest you please write the steps, then there is less chance of mistake. So this is the first step product. Now second step is Lindlar catalyst, so blindly you can write that one double bond will go, this is 1 CH CH2, this is, and the most important step is, student, the third step. So why I am saying do stepwise, then third step you can say that okay, this will be protonated and after that it will go, so here it will be a cationic species. So if this is cationic, and in the next step OMe will act as nucleophile, this enol-ether I have already discussed on this, so it will attack here this enol-ether, fine. So one side will, means one side will be, student, this double bond. So sorry, enol-ether will not attack here, enol-ether will attack here. Why? Because this can have conjugation and this is bulky. So obviously one side will be alkene having 2-methyl group, one side, and another side will be carbonyl. So one side means alkene attached to 2-methyl group, another is carbonyl, in which case alkene attached to 2-methyl group, this is not, so this is not. Now in this case only one double bond is possible, because this double bond will shift here, only one double bond, and after this it will be a keto, because nucleophilic attack is happening. So only one double bond possible, so option B gone. What is left? Option C. This is the right answer. So in exam you have to approach in this direction, and if you can come directly to the final product, that's a very good, I appreciate that. So this is, in this way you can come to the right answer, but I always suggest student read as much as possible. Okay, so in conclusion, what you have learned today, that ketone is electrophilic in nature at carbonyl carbon, and sodium acetyl is a very good nucleophilic carbanion. Lindlar catalyst reduces alkynes selectively to alkene or cis-alkene. This partial hydrogenation possible because of the specific combination of the catalyst. Finally, allyl alcohol can undergo facile protonation and water elimination due to the enhanced stability of the produced carbocation, and in this case the produced carbocation is both tertiary and allylic, and less bulky carbocation is preferentially attacked by the nucleophile. So that's why the reaction will happen from the less bulky side. And remember, these enolates are moderately good nucleophiles, moderately good, not very good, and this electron rich, actually these enolates are electron rich alkene, because it is in conjugation with, directly means double bond is directly in conjugation with this oxygen. Fine. And here nucleophilic attack happens from this carbon side because it's softer in nature. And finally, after the nucleophilic attack and workup, the enolate actually results in carbonyl compound, and as a consequence of this reaction, carbon-carbon bond formation occurs. Okay, so this is the end of discussion. I believe this video may be useful. I thanks everyone for watching this, and if you really consider the content of my channels are worthy, then please help this channel to grow. So thank you, stay happy, stay blessed, see you in my next video. Bye bye.